Now it gives me great pleasure to introduce our first speaker. And since he's Swedish, I learned that his name is Steve Berglund, but we can call him Steve Berglund. He's the CEO of Trimble since 1999, and please join me in welcoming Steve.
The topic this morning is the Internet of Things, and it's a bit ironic from the standpoint that in terms of the use of the phrase Internet of Things, I'm a very late stage comer. I haven't really used the term in terms of describing Trimble, and that's because Trimble really defines itself in a relatively unique fashion. Although technology and innovation are at the very center of what we do as a company, we're obsessive about defining who we are relative to our end user base, which we'll go through here in a little bit. And as a result, we tend to be quite eclectic in terms of the technologies we embrace, and actually, in a sense, agnostic relative to the technologies we use. And we'll see that also here in a few minutes. But the relative epiphany to me, once I got acquainted with the Internet of Things phraseology, is that the success of Trimble really is built on the Internet of Things. We were just too dumb to use the phrasing. There are a lot of things out there. Things in the context of Trimble tend to be something of a corner case, and that's where I'll stay in my comfort zone this morning and talk about those things. But things to us, yes, do include smartphones and the obvious elements of the Internet of Things. But in our vocabulary, it would also include bulldozers, it would include farm tractors, it would include pieces of structural steel, and trees in a forest. And so that's going to be the relative focus of this morning, truly down in the dirt. I would also suspect we are unique in Silicon Valley. We are the only Silicon Valley company, as far as I know, that does have a farm tractor parked in the back parking lot that we use as a test bed. So I think we are unique in that regard. The relative point here is not to tell you something that you already know, is that the number of connected devices is exploding, but to some extent, reflect on just how rapid change is, and the particular effects on Trimble. So I'm a 15-year CEO, a 15-year public company CEO, which means statistically I was dead a long time ago. I'm well into the corner case of longevity as a CEO, but just reflecting on the amount of change that's occurred in my 15 years. 15 years ago, we were active in field and mobile applications, but the fundamental architecture of the time was you collected data, you recorded on a device, and you brought it back to the office to do your work, to do your processing, whether you were a utility worker, a natural resource worker, a surveyor, or whatever. But the paradigm has dramatically shifted due to connectivity. At least until lately, the processing power available in a portable device and the access to data. The world has transformed itself and has created degrees of freedom that would have been unthinkable when I joined Trimble, which has required us as a company to reinvent ourselves, not just once or twice, but almost on a daily basis to take advantage of the advances in technology. Now, the other point of reflection probably is that in thinking about this, there is the Internet of Things, or the Internet of Connected Things. Okay, that's relatively easy to grasp. But then I think there's a second order definition that also is a fallout of the Internet of Things. We would regard every square meter of land cultivated in the world as being a thing that we're interested in. That square meter of land typically does not have a sensor on it. It is not connected in a primary sense, but the ability to get new insights into that square meter of land, or virtually any other thing out there, is a second order fallout. Because of the universe of connected things, our knowledge about other things has gotten deeper and wider and more useful. Again, we'll display some examples here in a minute. Again, preaching to a group that's probably already convinced. I won't spend time doing that. Lots of opportunity, lots of explosive opportunity in the Internet of Things. Let me, again, return to my comfort zone of enterprise, and actually a relatively narrow slice of enterprise, but to give you an idea. Now, in terms of looking at the Internet of Things in the enterprise context, just a handful of observations. One, our perspective as a company, our primary focus as a company is really about the transformation of workflows, usually in traditional industries. Now, okay, what does that mean? One is clearly productivity improvements, but coming from any number of sources, automation being an obvious candidate. Trimble guides farm tractors up and down agricultural rows to 10-centimeter level precision. There's still an operator in the cab, but doing nothing other than perhaps listening to music or reading a book. So automation is the obvious candidate. But then quality. Being able to monitor continuously allows a level of self-checking that has never been available before. So quality is potentially a step function improvement category here. And then increased safety is by monitoring an environment, by being connected into the Internet of Things and being able to monitor environments, it's possible to not send people into an environment that's inherently safe. An example out of Trimble's range would be mining, open pit mining. What is the slope of that mine wall? Is it at a safe slope or not? Is it safe to put a person in that environment? And being able to continuously monitor real time the slope of that mine wall is possible to understand whether the environment is safe. Or another instance in terms of correcting behavior. One of the businesses we're involved in is ready-mix concrete trucks. It's possible to monitor driver real-time continuously through the sensor array and the interconnectivity is to monitor driver behavior. Just an aside, of the roughly 75,000 concrete trucks in the US, approximately 2,000 tip over every year. High center of gravity, take a turn too quickly, and physics takes over. So you might want to think about that the next time you're next to one of them on a curve. But the third point here, the point solution is part of the solution, but brilliance in any particular point solution within the overall system is really secondary to the overall system performance. There is a major emphasis on playing nicely with each other within the overall system. So this is more than just about sensors. This is about the architecture that brings these sensors together in an environment that is optimal. The increased transparency and understanding leading to real-time decision-making. The ability to monitor things that have not been possible to monitor before, and this transparency and understanding can lead to kind of breakthroughs in terms of productivity. So for example, you can just imagine the pages of procedures that exist in this world that are lined up on bookshelves or maybe more these days in a virtual sense. But procedures really are there to keep to constrain the human judgments that's being applied to imperfect information. As you perfect the information, as you perfect the knowledge and improve the transparency into what's really happening, there is the ability to kind of rethink what is the nature of a procedure in terms of a more affirmative sense, but the ability to rethink the fundamentals of work. The disintermediation and recombination, giving a Trimble-esque example again. When we talk on the construction site, we talk about machine control, we talk about a bulldozer being intelligent, with the knowledge of where that bulldozer blade should be every second during the work process. Okay, what's happened here is the surveyors have been put out of a job function. The surveyors are no longer necessary on that construction site. They no longer need to come out and pound stakes in the ground or put string lines in, because the machine has become self-knowledgeable, and it's because it's connected. It has a computer on board, but it is getting design updates in terms of where that bulldozer blade should be from perhaps thousands of miles away. But the ability to tie the sensor into the data with the interconnectivity essentially allows entire work steps to be either reformulated or eliminated. And the power and influence. An example would be here, speaking as a CEO, potentially I can look into every operation in the company anytime I want to, so there is the potential here for, let's just call it breakthroughs in CEO micromanagement and intervention. I haven't come to grips with that one yet, but again, the idea of deep insight into the business, but then it allows entire work steps to be reconsidered, and so the Internet of Things has the potential here for fundamentally altering the nature of work. We'll come back to some specific examples. Now, the Trimble commercial, these are Trimble revenues since 1999. We have grown close to 17% annually over that time, with a hiccup in 2009 and 2010. We suffered along with the rest of the world. But again, I would say is in reflecting upon this, what has driven our success, it really is the Internet of Things in terms of the practical application of the Internet of Things in a number of different applications. Here are the 5 core businesses of Trimble, and the Internet of Things impact on all of these 5 has been profound and is becoming more profound as we move more and more into a big data realm. Agriculture, heavy civil construction, kind of horizontal construction, roads and runway type development. Building construction, the construction of a vertical building. Geospatial, the ability to put things in a geospatial reference. And these days, just about everything out there is getting a geo reference of some sort, sometimes to meter level accuracy, sometimes to millimeter level accuracy, and that's at the heart of where Trimble began and is still very key to us. Transportation and logistics. Where's my truck? What's the nature of the load? What's the status of the load? What's my engine temperature? What's my tire pressure? All of these sorts of considerations are becoming more and more key. And those represent the majority of Trimble revenues. We have a number of emerging businesses that are small at this point in time, and what we're attempting to do is recreate the success of the other businesses in these cases. So things like railroads, water, mining, public safety. Just as an aside, there are 150 different things inside a police car. I've never counted them personally. I'm told on good authority that there are 150 elements of technology in a police car, totally standalone, unconnected. And so next time you're stopped for a speeding violation, do me the favor of asking what software the citation is being written with. Would appreciate that. And an endorsement would be fine. When we talk about work process, let me try to define what we're talking about as a company. So imagine this is a work process. It could be thinking of an agricultural work process. The farmer sits in the farmhouse in the winter, looks at the data, decides what to plant and how to maintain that crop, buys the seed, buys the fertilizer, plants, maintains the field during the growing season, harvests, and then sends it off to market. So that is the fundamental type of workflow that we're talking about here. Now, Trimble talks in terms of 3 levels of interaction with that work process, all of them driven by the Internet of Things. One is task productivity. So taking the agricultural example, our first application in agriculture was steering this farm tractor up and down the rows to 10 centimeter level accuracy. pulling a fertilizer boom. Now, historically, that fertilizer boom, which is quite long with many nozzles on it, you'd come up and down and manually try to orient yourself. There was a tendency to overspray all the time and typically waste perhaps 10 to maybe 15% of the fertilizer. Through precise control, that was eliminated. But this is, as we learn more about the farm problems and asked ourselves the question every day, what can we do to improve the productivity of our farm customers? We started working more towards a view of process productivity, tying the various elements together, and created a concept called the connected farm. This has been the formula throughout in all of our different markets. And then eventually, it starts to converge in terms of looking at the entire enterprise, talking about optimizing the fleet, or looking at operator behavior in a fairly nuanced fashion, and saying, okay, how can we improve productivity through better training of our operators, for example? So a number of examples in all of these industries of this as the work process. Now, a key point, and really fundamental to us as a company, is what we need is interoperability between devices in an ecosystem and the applications that utilize those devices. The use of the word mixed fleet is a Trimble specific word, both for agriculture and construction. We've had a 10-year struggle with the manufacturers of heavy equipment from the standpoint of each of them wants their own proprietary standard in terms of bringing technology to either the contractor or the farmer. But the contractor does not want 5 or 6 or 7 different solutions depending on the color of the equipment out there. There is a need for each of them to interact with a relatively open architecture and share in a very democratic fashion. That is at the heart of what we're trying to do in terms of encouraging an environment of openness. Now, Trimble has, as I said, has redefined itself relatively continually. And this shows, I think, the relative progression of the Internet of Things, using us as an example. In 1999, we were a sensor company. We made GPS receivers as our primary point of focus, but then added other sensors. But then soon after 1999, it became possible to communicate wireless data at a cost-effective rate. And then the question got to be, we're generating all this data, how do we put it in context, let us into a concept of modeling? And then ultimately the question is, okay, we've got all this data, it's in a model context, we have it in some kind of context. The question is, so what? And hence the analytics. So analytics has become very central to what we do. Now, I have a large number of entrepreneurs in the audience here, so I want to just emphasize that Trimble is doing its part to support the entrepreneurial startup environment. This is the list of acquisitions over the last 13 or 14 years or so. Most of these were small, probably generally less than $15 million in revenue, tuck-in technology acquisitions. And so we have provided a path to monetization for any number of entrepreneurs. So if you're relevant, give us a call. The other perspective is international, which is 2 points. We've become a very global company. We have locations. We have people in 35 countries. We do business in 150, but I think the point here is 2 levels. One is global scale. That's important to be able to scale up. The other is the localization. Work is done differently in different places. There is a need to localize. So that is actually a somewhat of a paradox. We need to master the paradox going forward. Let me just quickly lead you through a number of our applications. Agriculture, again, connected farm from beginning to end, from kind of planning through to harvest and shipping off to market. But then I think the other thing is looking at the full implications of the Internet of Things in the context of agriculture, which is every square meter, again, has an information ecosystem. The combination of connectivity, data, and sensors enables it to be put together, and so that a precise prescription can be established for each square meter. This shows what is going on in every square meter in the agricultural field. And this all comes together, again, showing the full power in a specific application of the Internet of Things. This is what the farmer is looking at in the cab, which includes irrigation data. It includes the ability to pull together every aspect of the farm in one format that can be accessed effectively. Again, just flipping through quickly, again, the full nature of the farm. Heavy civil construction, again, very much the same. That bulldozer blade is being controlled to centimeter level accuracy from data that's maybe being generated 2,000 miles away by a design engineer. Building construction, again, very same story of eliminating a waste. Here's an example of a construction crane that is focused on, keeping them from colliding, but again, referring to an ultimate database that becomes part of the supply chain. So that piece of structural steel I referred to earlier, knowing where it is, going to a specific location, picking it up, and dropping it in. Again, being able to, from a construction standpoint, referencing remote databases, being able to do positioning and layout and things that were historically had to be done in a very manual sense. Transportation and logistics, very much the same. When we talk about things, let me point out that things can include tracking the seismic plates, the continental drift, and that's one of the applications. Again, a real-time, continuous application of monitoring drift. The reverse RFID, just dropping that in because RFID is central. The Trimble concept here is that the tag would be on something like a first responder who's being referenced positionally to an existing infrastructure, or a piece of structural steel with a tag on it, and being reestablished, its position being reestablished every time a vehicle with a reader goes by. Considerations and implications, organizational design. The Internet of Things, I think, allows radical concepts in terms of organizational design. Things like traditional span of controls and accountabilities can be reconsidered because of the availability of data. Monetization and the potential diminishing returns of information. There's an awful lot of information out there. What's worth what, and what's the priority, because there's only so much money that ultimately is available. Commoditization of high-value business models. I talked to the surveyor. That surveyor's role has to change because the traditional role will disappear. The sensors collecting data at various degrees of quality and coming up with an answer. How do you take data from varying qualities or varying levels of quality and combining them into a quality decision? And then I think the consequences of mission-critical failures. System complexity creates issues. Security creates issues. And then I think the human and system handoffs require issues. So that is what I have to say on the Internet of Things in my own little corner of the world. Appreciate your time and attention, and have a good remainder of the conference. Thank you.